Hi everyone. So this is the fourth part on the first topic, introduction to materials. So we started in the last recording discussing the different types of materials and some of their qualities or their properties, briefly of course, just to give you a general idea about each of these 5 major categories. So we continue today with this new recording on the types of materials. So last time we just listed up the 5 major types of materials: metals, ceramics, polymers, composites, and semiconductors. And today we will have a brief look to some of the major properties and characteristics of each of these 5 major categories. And in addition to that, we will introduce 2 new categories that are not really very popular, but that are also considered as, part of the types of materials. So the classification of materials as we briefly discussed in the last recording, it's linked, of course, to their chemical bonding mainly. And the chemical bonding determines, of course, the class of the material and also their properties. So mostly the chemical bonding is the key parameters in the classification of materials. So metals, as we have seen, that the first, let's say, the first category. So metals are having, of course, metallic chemical bonding. They are bonded with a chemical bonding. And of course, the main properties of metals is the heat conductivity. So they have the heat and the electrical conductivity, of course, both. They have a high electrical conductivity, and this high electrical conductivity is due to the type of chemical bonding, which is metallic bonding. So the electrons are not bonded to specific ions or to specific atoms. They are forming like a sea of electrons. So we'll see this in a bit more details in the next chapter when we discuss the chemical bonding. But here we are just discussing the general information about these 5 major categories of materials. So many properties of the metals are, of course, attributable or are linked to this chemical bonding of metals, which is, let's say, forming a sea of electrons. So the electrons are free to move and to bond to any ions and to any atoms. They are not specifically bonded to one specific atom. So this mobility of electrons gives a high electrical conductivity and high electrical thermal conductivity, in addition to other properties, of course. So some of the major properties of metals: they are strong. They have most of metals, they have high strength. They are also deformable, so you can deform the material. You can see here some examples. So deformability is one of the key properties of metals. So you can deform it, you can make it in a different shape without, of course, rupturing the material. But this property is not really found in ceramic materials. So ceramic materials, if you try to deform it after, of course, casting, you will break it because it has no ability to deform. Also, as we said, most of metals are ductile materials, but there are few metals in a specific state, they are brittle. And we said the the difference between ductility and brittleness, of course, is in terms of deformation, plastic deformation. So ductile materials, they have a large plastic deformation, and they show large deformation, plastic deformation before rupture, while brittle material, they have very little or no plastic deformation before rupture. Anyway, we'll discuss ductility and brittleness in chapter 5 or 6, properties of materials. Also, metals, they have very good, even excellent, so of course, depends or different from one material to another material. But overall, all metals, they have very good conductivity to electricity and to heat. And also they are shiny if polished. If you polish the metal, of course, it will shine. It will it will be very bright. So you can see just here the difference between when you shine these two objects before and after the polishing. So you can see this is more shining than this one just because of the polishing process. So this gives unique properties. So if you try to do the same process on plastic or ceramics, it doesn't work. So this is a process of polishing. So we have different applications or uses of metals. Of course, metals, we have seen a large varieties of metals, not only steel or aluminum or copper, but we have a very large list of metals that are used for different applications. And you can see just here very few examples on the use of metals in a different application. So you can see from parts of engines or equipment to a pipe use to reinforcement material, use it for making structure in concrete, to some simple house items that are used for domestic use. So this is just a few examples, and you can think much more about other examples that you can see in your daily life where metals, different types of metals are used. If you just look around you in your house, you will find several items that are basically made with metals, different types of metals. But at least in civil engineering, in construction, you understand that metals are having a great and principal place in construction. So you can see bridges. There are many bridges are constructed using, of course, metals, and especially in the past, most of the bridges were constructed using metals. But now, of course, we are having much more bridges made with concrete than with metals. So this is for a different reason. We can discuss it in other occasions and other topics. You can see some examples of bridges. Golden Gate Bridge that was inaugurated in 1937 in San Francisco. So this bridge is completely, you can see here, suspended bridge is made with metals. So why metals are the material of choice for making bridges? Because of the properties, of course, of metals, strength and deformability. So easy to deform and easy to have plastic deformation. So it doesn't rupture suddenly as brittle material like ceramic materials. Here you can see other examples of bridges. Here it's pedestrian walkway. So this pedestrian walkway, 66 meters. You can see here it is also made completely with steel, or probably with steel, but generally we can say just with metals, because we don't have precise information about which metal has been used, but in most cases, of course, it is the steel, which is largely used for as a construction material. Also, you can see here another example of a very long bridge in Incheon Bridge. This is in South Korea, in Seoul. So the total length, you can see it is a huge one, 21.38 kilometer long, and it is the length over the sea is 12.12. So over the sea is 12.12, and the rest, of course, is on the land. But it is overall, it is one of the largest or the longest bridges in the world. So this is also another examples of the use of metals in construction, and mainly to make bridges. Yes, you can see here it is considered as the fifth longest cabled bridge. So the cables, we are talking about these cables here. So this is specific type of construction or mode of construction of bridges. And you can see here the steel plate or the span between the support. So it is 800 meter, which is a very long span, of course. So just before we finish with the metals and move to the second category, so just I think you're all familiar with this table. This is, of course, the periodic table of element, chemical element. And what are the metals here in this table? So, of course, the metals are the shaded area, the blue boxes here, the blue element, the colored element here are the metals. So you can say it's most of the elements in the periodic table are metals, of course. But of course, the most used element, of course, as you know, is these elements here that are colored with the red color: aluminum, zinc, copper, nickel, iron, titanium, magnesium. So this is the most largely used metals, and from these metals, combining these two metals together, so we can form also a new category called the alloys. So metals, you have many possibilities in metals. Either you use the metal, single metal itself, or you can combine it with another metal. Of course, there is all science behind that. That is called metallurgy. How you combine different metals together to form a new metal, which is called an alloy. So in periodic table, of course, you can extract many information. So you can see always depends on the design of the periodic table, but in most periodic tables, so you can find the symbol of the element and the name of the element. What does mean this symbol here? Because the symbols are not English symbols, are Latin symbols. So sometimes you might just like the, I'll just give you an example, like the Fe. So Fe in English, of course, is iron. So from where it comes, the Fe, it comes from the Latin, which is fer. So the first initial Fe, it is referred to the Latin, not to the English name of the element. So you can find the symbol, the name, and also two major informations. You can find also the atomic number on the top and the atomic mass on the bottom. So like this, you can get at least a few key information about each element from the periodic table of the element. Here is just an example also of different elements, mostly are metals here, and their engineering or their properties. So you can see here the symbol, the name of the element, and also some properties like the melting point, physical properties, at which temperature this element will melt, will be like liquid, will be transformed from solid to liquid. And you can see from one element to another one, from one metal to another metal, you can see the temperature is largely different. So this is why they are all metals, but their properties are largely different. So if you take just example, any example here, let's say zinc, the melting point of zinc is quite moderate, 700, or this is Fahrenheit, so we can take just the degree Celsius for 419. But if you just look to zirconium, so it has very high, mostly 5 times or 3 times or 4 times higher temperature, melting temperature, 1852 for zirconium compared to zinc, and so on. So the properties are different among the metals themselves. Also the density, you can see the change in density. So there are few elements, they have very high density, like these elements here, like iridium, like the osmium, like the tungsten. But there are other elements which are lighter, like you can see here, aluminum and calcium. They are much lighter than, of course, than other elements. So physical properties also like density is also largely variable among the different elements. You can see here also electrical resistivity. So they are all conductors, but they have a different electrical resistivity. Also, coefficient of thermal expansion, how they expand if they are subjected to change in temperature. So it is also largely variable, and also thermal conductivity. So usually, of course, metals are conductors, are not, of course, insulators. So of course, we expect that most metals, they have a high thermal conductivity, at least much higher than, of course, the ceramics or the polymers. But this table here, of course, it's not only for metals. There are some other elements which are not classified as metals, of course. Like you can see, mercury is included in that table. So, but mercury is not really considered as what is mercury? Hg. Normally, mercury is not considered as a metal. Where is mercury here? Anyway. So this is just a very brief introduction on metals. And of course, throughout the course, we will learn a bit more and more about metals, and specifically about steel and somehow aluminum. Then we move to ceramics. So ceramics is also one category of metals, and ceramics are known that are inorganic materials, and also they are non-metallic. So two major characteristics of ceramics material. They are not metals as pure metal, of course. You will see to form ceramic, it is very funny. To form ceramic, you need a metal element plus oxygen. So it will be transformed into a ceramic material. But as pure is not metal, of course. And also they are inorganic materials. So this is two major characteristics of ceramic materials. Also, usually to process ceramic materials, usually you need high temperature. Unlike, of course, polymers, we will see later on, and also metals. Metals sometimes they need a high temperature, but for some metals, we need just a moderate temperature. So mostly ceramics mainly are made with silicon. So silicon is the main element that make ceramic materials. Si. Si is the silicon bonded with non-metallic elements such as oxygen or carbon or nitrogen, and with metallic compounds. So this is what I told you. So it's usually a combination of metals. So to form a ceramic, you need a metal Mx, let's say, and or semiconductors like silicon with oxygen. So M oxygen, or it could be in some cases nitrogen or carbon. So it will be oxide or nitrite. Oxide if it is combined with oxygen, of course, or nitrite if it is combined with nitrogen, or carbide if it is combined with carbon. So I'll just give you an example here before we go further. Think about an example here before I give you my example, but at least you can think about how combining metals and oxygen you form a ceramic material. Think about any example. I already gave you some of these examples. So let's say aluminum. Aluminum, this is a metal, isn't it? Al2O3. So this is, now it is formed as ceramic material. Combining aluminum, which is a metal, and oxygen, we form a new material, which is called the ceramic materials aluminum oxide or aluminum. And you can think about calcium oxide, about silicon dioxide. This is why we said also it could be combined also with the semiconductors, metals or semiconductors, because Si is considered as semiconductor. So Si, O2, silicon dioxide. So this is also ceramic materials, but here we combine silicon, which is a semiconductors, with oxygen. Anyway, so this is how ceramics are formed. Combination between metals and oxide, or nitrite or carbide. But in most cases, this is the most common cases, combining metal with oxides. And you can think about many examples. Aluminum oxide, iron oxide, calcium oxide, silicon dioxide, and so on. Magnesium oxide. So some properties of ceramic materials. They are hard materials. They are not soft, of course, as compared to polymers. They are also brittle, so they are not ductile like metals. So they break suddenly if you reach the maximum load. So they will break suddenly without any plastic deformation, or with a very little plastic deformation. And also they don't conduct electricity or heat. They are not perfectly insulators, but they are not conductors. This is the most important. So this is at least three major properties. So physical, mechanical, and thermal and electrical properties of ceramics that distinguish ceramics from metals and other materials. So they also have usually good compressive strength because they are hard. So they are somehow strong also. And also they can resist to high temperature and harsh environment better than metals and polymers. And I will just give you an example. If you want to put your food in an oven at high temperature, what do you put usually? You put metal or you put ceramic plate. So usually ceramic plates is used. And also in other industrial applications. So whenever it is there is an oven, so at high temperature, so usually it's covered inside, at least if it's not fully. So it is with ceramic materials because they have the ability to resist to very high temperature, as compared to, of course, polymers. They cannot resist to high temperature, or metals also. they can start melting if they are exposed to high temperature. And also they have a good resistance to environment. So you can see just a very simple example. Metals, if they are exposed to environment, especially some specific environment, they start corroding. You can see the corrosion. I will just go back here and I will just show you example that we have already seen. So you can see here, this is what we call a corrosion. So this metal has been subjected to corrosion. You can see here the signs of corrosion and deterioration of the metals due to environment, of course, because this is used outside, outdoor. So this is called deterioration due to, of course, to harsh environment. But ceramic materials, they have very good resistance to harsh environment compared to metals. Some examples of some ceramic materials, of course, ceramic materials are largely used in different applications. At least you can just look around you, you can find glass bottles. Glass, of course, it's part of ceramic materials, while sometimes we just put it in a separate category, but it is belong to ceramic materials. You can see some pottery examples, some domestic and items, household items. And of course, in your home, you will find, of course, many items that are using dishes and so on, that you are using in a daily life basis, that are ceramic materials, whether you know it or you don't know it. But at least from now, you know that these materials are called ceramic materials. So as I said, just to form ceramic materials, you need to combine metal with oxygen. This is the most common case, of course, but it could be also with nitrite or carbide. But the most common is forming ceramic by combining metals with oxygen. Also, one of the properties of ceramics are they are chemically stable, so they don't react easily with chemicals. So they have quite a high resistance to chemical attacks. Also, melting temperature is very high compared to, of course, to metals and to polymers. And this is why they are used for refractory applications. Wherever you have applications where your structure or your material is exposed to high temperature, so ceramic materials are recommended rather than metals or polymers. Also, we said they have high strength, but the weakness is the brittleness. So this is why you will find ceramic materials used for furnace, used for chemical processing, because they have a very good resistance to corrosion, to high temperature, to chemical attack, to so on. So just an example of ceramic materials formed by a combination of aluminum and oxygen, as I told you earlier. So alumina or aluminum oxide. So the melting temperature of this compound is 2020 degrees Celsius. So very high melting temperature. And here you can see just as an example, the melting point of different metals or different materials, including ceramics and metals. And you can see we have some materials, they have low and very low melting temperature. But on the other hand, you can see there are some metals or some materials, they have very high melting temperature. So like you can see here, tungsten has very high melting temperature, almost 3,500. But on the other hand, you can see some other materials like polyethylene, polymers, most polymers, they have a very low melting temperature, like as you can see here, polyethylene and polypropylene and so on. So one of these physical properties, of course, is completely different from one material to another material. Why melting point is important for structural design? Think about this: how the melting point of material, how this information about the melting point of temperature of materials is important in your structural design. As an engineer, you will be requested to choose or to select a material for your design. You can see also here, just example, of course, it's not something that you need to remember or to memorize, or it's just examples of physical properties of some materials, and they are ranked here by descending order, so from the highest to the lowest. So you can see, if you take a density, of course, you can see here how these materials, they have a high density compared to others, and you can see here from the bottom, you can see plastic. Plastic has the lowest the density compared to, of course, some metals here, and even compared to some ceramics. So you can see glass has a much lower density compared to tungsten or gold or lead or whatever, but also it has a higher than plastic, and so on. So examples. Melting point also, you can see here it is in, and you can see plastic also has the lowest always. Plastic has the lowest density, the lowest melting point. Specific heat, of course, it is not classified plastic here, because usually plastic, they have a very low melting point, so they don't have ability to store heat, and this is what we call it specific heat. So storing the heat and then release it. You can see also thermal conductivity. So the good thing for plastic, so it has low thermal conductivity, and this is, of course, it's a property that is required and appreciated for many applications. So for many applications, like for housing and buildings, of course, we are not looking to have a high thermal conductivity. Opposite, we are looking for low thermal conductivity. You can see glass. This is why glass is getting more and more used in construction, because it has low thermal conductivity compared to other materials. But of course, for some other applications, we need the thermal conductivity. So it depends on the use and the application. Thermal expansion, same thing. So you can see here the opposite thing. Thermal expansion, plastic is in the top list, and then tungsten, which was almost always in the top list. So now it is in the bottom list. So these materials, they have a different behavior when it is exposed to thermal or to heat. So some materials, they expand, like plastic expand very high. Some others, they have less expansion, like glass. It has very low expansion when it is exposed to thermal treatment or to heat. Lastly, here we can see in the last column on the right side, so electrical conductivity. So also materials, you can see here, they have very large differences in terms of electrical conductivity. So you can see some materials are in the top list, like silver, copper, gold, especially silver and copper. This is why they are used for cables, for most of electricity wires. You can see they are made with copper, as far as I remember, of course. And then it comes aluminum and other, but copper, I think, is the most used for making electrical wires, and also phone wires, because they have a high electrical conductivity compared to other metals like steel. Steel is not used for making electrical wires, because it doesn't have a very good electrical conductivity. And then you come here to the bottom list here. So plastic, quartz, glass, ceramics, they have very low electrical conductivity the lowest, because they are not supposed to conduct electricity. So this is just a very brief overview about the properties of materials and how materials are classified. And the use of ceramic materials, it's not only for domestic use. You can see here there are many other uses. So from pottery, from even the engine of cars and other equipment now, we are introducing some small parts that could be used, that could be manufactured using ceramic materials rather than metals. So even engines of some machines, equipment, and so on. So they have some parts they are made with ceramic materials because of the need for some specific properties like hardness, like also high temperature resistance, and so on. So if you take in this kind of engine, you will find all the types of materials. You will find metals, you will find polymers, you will find ceramics, and so on. Glasses, as we said, of course, it is belong to ceramic materials, but sometimes you will find them in a separate class because they have quite unique properties compared to other ceramics. So this is why in some references you will find the glass as separate category, but they are still belong to, of course, to the ceramic materials because they are formed in the same way. So glass usually it has a high concentration of silicon dioxide, SiO2. So usually around 70% and above of silicon dioxide. In addition to that, of course, you will find also other element like calcium oxide, lime. This is called lime. And also you will find sodium oxide, potassium oxide, and other element, but it is dominated by silicon dioxide. This is why glass is mostly fabricated from sand. Not all sand, of course, but siliceous sand. So sand is the main raw material to form or to make glass. But of course, it has to be sand with silica, not any sand. Because if you can take sand from wadi or rivers, of course, this sand is not rich with silica. It has much more other element than silica. It has some silica, but it's not enough for making glass. So glass is known to be non-crystalline, as we said. It's amorphous material. It's not crystalline material like other ceramic materials. And this is why one of the reasons why it is classified like separate category. Some of the major properties of glass that makes glass very good material for some applications. You can see applications are very large for glass, and we will see some other applications. So transmission of light. This is of course the most known and the most visible property of glass. So glass has the ability to transmit light, and this is what makes glass a unique material for this property. So whatever you need to have this property, optical property, of course, the material to choose is, of course, glass, without any discussion. Also, they have good resistance to chemical attack, so they are chemically inert, and also they have a good strength, but they are brittle, of course. As we said, brittleness is one of the characteristics of ceramics materials, including, of course, glass. So glass is used in different applications, in a large variety, from industry to your house, your house items to laboratory. You can see laboratory mainly. If you go to chemical laboratories, you will find many many scientific glass blowing, and so glass, because it has a high resistance to chemicals. It is quite inert. When you put chemicals in the glass, it does not react. And there are some chemicals like acids, they never pack it in plastic, they always pack it in glass. There are some other chemicals that they are sold out and they are stored in plastic. So you can see the advantage of glass here. And you can see the applications of glass just in your house. Just look around you, you will find the glass is used for food packing containers, for glass bottles, whether for beverage or water or whatever, and also for construction, which is our main, of course, our main purpose. So you can see glass is largely used for making tables, making even chairs, making stairs, even making structural element, not properly speaking structural element, but walls. You can see here the wall is completely, not completely, but except, of course, the supporting element or the structural element. So the rest of the wall is made up with glass. The doors, the whole wall here, you can see it is made up with the glass, unless of course this joining metals which are used of course to support the glass. So you can see the glass is largely used even in construction, and it has many applications because of these unique properties of transmitting light. So we will get the natural light instead of being confined in a structure that is made with metals or other ceramics that are not transmitting light. So using the glass here, you can see the whole beauty of your surrounding environment, and you can save energy by using this free light, natural light, rather than the artificial light that you consume more electricity, and also you don't enjoy the natural light. So I will stop here for polymers, and then or maybe next time, of course, we'll start from here, from polymers, because it's getting around 40 minutes. They don't want to make it much larger than that. So next time we'll discuss the other properties, how the other materials, categories of materials, polymers and composite and semiconductor.